Hello students, now we are going to start unit number 18, atoms and nuclei. A very important unit. Basically, hydrogen spectrum and radioactivity are the important parts of this unit. So we will discuss one by one. First, we will discuss about Rutherford's experiment and Geiger and Marsan's scattering experiment. By that experiments, they proved that in atom, positive charge is only at a small portion situated at center, known as nucleus. Means in an atom, material is only in very small portion, and that is situated at center. Whole mass of atom is nearly in this place, which is called nucleus. If atomic number of an atom is Z, it means Z protons are there in a nucleus and Z electrons are revolving around the nucleus in fixed orbit levels. From where they got the idea? Because when they bombarding by alpha particles, they get a result that some alpha particles rebounded back, but mostly will pass through and deflected by a little amount, but the particles which were going towards the center of atom, they were rebounded back. What was the reason? Up to what distance that alpha particles cover in the atom? Means if we want to calculate the nearest approach of alpha particle, we can calculate it by the concept of potential energy. We know that alpha particle has a positive charge equal to 2 electrons, and nucleus has a positive charge, it is Z into E. You gave kinetic energy to the particles. You gave kinetic energy and particles were moving with kinetic energy half mv square. Your alpha particle was moving with this kinetic energy. When they are approaching the nucleus, a repulsion was there. When this whole energy is spent against the repulsive force, means whole energy is converted into potential energy, it will come back. So we know the formula for potential energy, 1 upon 4 pi epsilon naught Q1 Q2 by R. R is the nearest approach. So by this you are able to calculate the value of nearest approach. So what it was? It was 2 Q1 Q2 by 4 pi epsilon naught m v square. And what is Q1 Q2? We know that you sent alpha particle, it is 2e, and that nucleus that have charge Ze. Now you can cancel 4 with 4. So you will get this formula for closest approach. If in examination or in your competitive exam they are asking, you can easily tell this closest approach should be ZE square upon pi epsilon naught mv square. They can confuse you, or they can make a new problem with this concept. They will say कि suppose closest approach or nearest approach for alpha particle is R in an atom whose atomic number was this, suppose they say 10. If we bombard alpha particle on an atom whose atomic number is 30, what should be the closest approach? See the formula, only focused on atomic number and R. Both are in numerator, means R is proportional to Z. If atomic number of second element is 3 times, closest approach should be 3 times. In this way, we will get the answer. Now we are moving towards Bohr's atomic model. Very important. Only means 90% you will get problem. Bohr's atomic model of hydrogen-like atom. Maximum problem, 90% you will get problem from this portion. See, we will discuss in detail each and everything for the crash course, so that you should be able to attempt all problems for this portion. What is happening? Bohr put some postulates that electrons are moving around the nucleus in fixed energy levels. Neither they are radiating energy nor absorbing in simple case, but if they are getting energy from outside source, then they will jump to higher energy level. But when they are simply revolving around the nucleus, they are orbiting around the nucleus, they are not radiating any energy. Number 2, the angular momentum of electron is integral multiple of h upon 2 pi. H is Planck's constant. It was most important postulate of this theory. Angular momentum we know from rotational motion. If radius of orbit is r, means suppose your electron is orbiting in nth orbit. So we are putting its velocity there, Vn and Rn. It should be n times h upon 2 pi. It should be n times h upon 2 pi. Means angular momentum, since n is quantum number, for first orbit principal quantum number it is 1, for second orbit n is 2, so n is integer. So we can say that angular momentum is always an integral multiple of h upon 2 pi. It was most important portion of that theory from which our calculation will start. We know that electrons are orbiting in circular orbits, so they need centripetal force. From where they will get centripetal force? They need this force. From where they will get this? They will get this from electrostatic attraction between electron and nucleus. If atomic number is Z, nucleus has how many electrons? Z electrons, Z protons. Nucleus has Z protons. So attraction between nucleus and electron, it should be Q1 Q2 upon R square. Two unknowns, Rn and Vn, and two equations are there. So we are able to calculate what you want to calculate. Cancel one Rn with one Rn. Put the value of Vn, you will get the value of Rn. If first we want to calculate Rn, what is Rn? Ze square upon 4 pi epsilon naught. What we are getting for Rn? Ze square. We are taking Rn at this place and this we are taking there. Or we can save our time. We write this mvn into vn. We can write this mvn into vn 1 upon 4 pi epsilon naught Ze square by Rn by Rn. mvn we can put nh upon 2 pi Rn. nh upon 2 pi Rn. mvn nh upon 2 pi Rn. 1 Vn is there. 1 upon 4 pi epsilon naught Ze square by Rn. So first we are calculating, cancel pi with pi, 2 with 4, Rn with Rn. First we are getting Vn. What is Vn? Ze square upon nh 2nh epsilon naught. Ze square 2nh epsilon naught. So I am writing here now Vn is equals to Z put separately E square upon 2h epsilon naught. What is remaining? E square is there, 2 is there, h is there, epsilon naught is there, Z by n. Why I am separating it? For different orbit, we have different values of n. For different elements, we have different z. For this number is same for all. Your calculation will become easy if you put c here and c here. Means epsilon naught square upon 2h epsilon naught c. Its value if you calculate. Why I do this? Because velocity dimensionally equal to velocity, and these are pure numbers, quantum number, principal quantum number, and it is atomic number. They have dimensionless. It means velocity is velocity, so this number is also become dimensionless. If you calculate its value, you will get 1 upon 137. So only you have to remember number 1 upon 137. for all numericals. Now we are getting this into Z by N. See, this number is known as Sommerfeld's fine structure constant. What is it? Sommerfeld's fine structure constant. It is same for all. You can denote it by alpha. You can denote it by alpha. So Vn we are getting 1 upon 137. Suppose in any numerical they are asking you, in a sodium atom in a third orbit, what should be the speed of electron? In sodium atom in a third orbit, with what electron, with what speed electrons are revolving? I can solve this now. How I can solve? See, 1 upon 137 is constant. Sodium Z is 11. Third orbit, it should be 3. Speed of light, you know that 3 into 10 to the power 8. So what we are getting? Take 1 0 with 110 or 2 0, 1100, it is 137. Divide 1100 by 137 into 10 to the power 6 meter per second. You will get the speed of electron. So now we are able to calculate speed for each and every orbit of every element of your periodic table. Only to tell the speed, we know the atomic number of that element. So here once problem is solved. Ki for whole periodic table, now you are able to tell the speed of electron in any orbit. You have to learn only this fine structure constant 1 upon 137 Zc by N. So one most important result, we make it for you. If we put the value of Vn in any relation, suppose we use this relation in which Rn was there, we are able to calculate the value of Rn. In next page, we will discuss about now Rn. We are using two concepts. Now we are trying to calculate Rn. First, Bohr's atomic models important postulate कि angular momentum in each and every orbit is integral multiple of h upon 2 pi. We are talking about nth orbit. Speed is Vn, radius is Rn, n is principal quantum number. For first orbit 1, second 2, third 3, fourth 4. Second concept we are using कि every particle, charged or uncharged, if it is moving in a circle, particle needs centripetal force which is equal to mv square by r. mv square by r. Nth orbit, we are putting n here. From where it will get it? It will get it from attraction, electrostatic attraction between nucleus and electron, 1 upon 4 pi epsilon naught. Nucleus charge Z into E, electronic charge E upon r square, radius of that orbit. Cancel Rn with Rn. So what we are getting for Rn? For Rn, we are getting now Ze square divided by, we are taking Rn in place of mv square, 4 pi epsilon naught as it is at its place, taking m and Vn square. So we are getting this. So by putting the value of Vn from this, what we are getting? Ze square upon 4 pi epsilon naught m. What is the value of Vn? N square. We want Vn square. But what is Vn? From this, Vn is NH upon 2 pi m Rn. Vn is NH upon 2 pi m Rn. So Vn square means n square h square divided by 4 pi square. What is the value of Vn? NH 2 pi, it is m. 4 pi square m square Rn square. Cancel Rn square with this. Take all physical quantity on that side. We get the value of Rn. Cancel 4 with 4. 1 pi with 1 pi. 1 m with 1 m. So what are remaining? Take this n square h square on that side. In a denominator, z e square pi m. This. Separating n and z, what we are getting? H square. This epsilon naught is also there. So n square h square and this epsilon naught. So h square epsilon naught divided by e square pi m. Remaining is n square by z. Again, all numbers are constant. H square epsilon naught and this z we separated from this. So pi m e square h square epsilon naught all are constant. You know the value of each constant. H is Planck's constant 6.63 10 to the power minus 34. Epsilon naught 8.85 10 to the power minus 12. E 1.6 10 to the power minus 19. For all elements of periodic table, pi is 3.14. M electronic mass 9.1 10 to the power minus 31 kg. So if you put all the values, remember this number, you will get point and unit. You know that n and z are dimensionless. Distance can be equal to distance only. So this term should have dimensions of length. So you will get 0.53 angstrom. For this number you will get this. Remember this. Now like Vn, you are able to calculate radius of each orbit of each element of your periodic table. Only which orbit you want to calculate, for which element you should know that only. Suppose we are talking about minimum value of Z for whole periodic table, minimum value of Z is 1. No element with 0 atomic number, and it is for hydrogen. It is for hydrogen. If you want to calculate for hydrogen, it is special first element, and we are choosing first orbit, means we are taking Z and N1. We are talking about hydrogen and we want to calculate radius of first orbit. So what you will get? It is special, so we are denoting with R0. You will get 0.53 angstrom. This radius is known as Bohr's radius. It is known as Bohr's radius. Getting my point? It is Bohr's radius. Means radius of first orbit of hydrogen atom. Now you are able to calculate for all elements. Suppose you want to calculate radius of third orbit of carbon atom. We know that its atomic number is 6. So Z is, its atomic number is 6. We want to calculate 6C12 carbon atom. R3, radius of third orbit, Z is 6 and N is 3. Now easy calculation for you. What should be its radius? 0.53. I am talking about angstrom, taking unit angstrom, into N square, 3 square is 9. Carbon atom, Z is 6. 3 2s are, 3 3s are, means 1.5. Only you need the table of 15. Easy. 15 3s are 45. Carry 4. 15 5s are 75. 79. Decimal after 3 place. So what we are getting? 0.795 angstrom. It means radius of third orbit of 6C12 carbon atom, it should be 0.795 angstrom. So getting my point? So now we are able to calculate radius of each and every element of periodic table, and you are able to calculate radius of all orbits. From this you are able to calculate velocity of all elements, all electrons of any orbit for any element of periodic table. So now we have two important results. So it is easy for you now to calculate radius and velocity.